Hey guys, Mr. Briding here to go ahead and explain to you guys what Newton's 3 laws of motion are. Now, if you've already watched the vocab, this should just kind of help you out. If you have not watched the vocab, I highly recommend you go back and watch the vocab video. But anyways, Newton's 3 laws of motion, it just kind of tells you how things move and how they react to forces. So they are in a very good order, and it makes perfectly good sense how they're ordered. And I'm going to kind of describe to you guys the Newton's 3 laws in terms of that order and force. Okay, so the first one, it's kind of called the law of inertia. So Newton's first law can also be called the law of inertia. And it pretty much just says objects are lazy. So this guy here, he is not going to move. He's going to stand still unless something actually acts on him. So if something pushes or pulls him, then he'll accelerate. But if nothing pushes or pulls him, he has no reason to do anything at all. On the other side, if something is already moving and already has a velocity, that velocity will never, ever change unless an outside force acts on it. Okay, now this is actually kind of hard to observe on Earth because there's always a force acting on us or any type of object. But let's imagine there's an asteroid in space and it's going 1,000 meters per second. It will go 1,000 meters per second for eternity if no force acts on it. Okay, so again, that's called inertia, and Newton's first law is just talking about when there is absolutely no forces. Alright, now Newton's second law then says, alright, well, if I am pushed or pulled, what will happen is my velocity will change in one way or another. Okay, what that means, again, it will accelerate. Now there's 3 ways to accelerate. You can speed up, slow down, or change direction. Okay, now the harder something is pushed, the more it accelerates. Okay, so again, if you think about the equation, so we have force equals mass times acceleration. Okay. Also, on the other side, we have acceleration equals the force divided by the mass. Okay. So acceleration is going to be proportional to force. Okay. And inversely proportional to mass. So if mass increases while force stays the same, then acceleration is also going to change. So very large things are going to accelerate less than very small things. And this makes perfectly good sense. If you push a baseball with the same force that you push a 16-pound bowling ball, the 16-pound bowling ball is going to accelerate much less than the baseball is going to. So again, these are just basic observations being explained through an actual law and through numbers. Okay, so again, mass, we can also calculate mass using this equation, which is going to be the force divided by the acceleration. Okay, so again, mass and acceleration are inversely related, while force and mass, or force and acceleration, are directly related to each other. Alright, so that's pretty much it for Newton's second law. Go on to the third law. So the third law pretty much says, let's imagine we have one force. Okay, so the orange ball crashes into the black ball. Okay, now as you can see, they crash into each other right here, and there is a force put on the orange ball and a force put on the black ball. The force put on the orange ball is the exact opposite of the force put on the black ball. So the force put on the black ball is this way, as you follow the red arrow, and the force put on the blue ball is this way, the blue arrow, and you can see that they are equal in size. So the third law says that for every force, for every push or pull, there is an exact opposite push or pull. And again, this is all things that we can easily see in everyday life. If I go to pull a wagon, okay, the wagon pulls back on me and I pull on the wagon, okay. You can see down here that, again, the direction of the forces is going to be exactly opposite. Same thing down here. Even if there's a small force, they will be exactly opposite. So in summary, here's pretty much what I said. Newton's first law tells us what objects do when there is no force, and that is that objects are lazy. When there is a force, Newton's second law says that things accelerate, and they accelerate depending on their mass and the force provided. And then Newton's third law pretty much says that every force that there is, for every force that there is, there's an equal and opposite force. So write down any questions you have. Hopefully you took some notes. Don't forget to press the pause button and rewind. Other than that, see you guys next time.